Well, Oracle's making moves again, and they're trying to reset the bar for distributed databases. With its latest announcement, globally distributed Exadata Database on Exascale infrastructure, Oracle is signaling that it's not just participating in the distributed database trend, but it's seeking to own it, in our opinion. But Oracle's not alone. The market is filled with new entrants and existing players. And as always, Oracle's leaning into its strengths. So full SQL compatibility, mission critical scale, advanced replication techniques, and deep automation. And it's doing so with key investments in AI enablement, where agentic AI and data sovereignty are shaping the future of enterprise workloads. Hello and welcome to this CUBE conversation. My name is Dave Vellante, and with me is Wei Hu, who's the Senior Vice President of HA Technologies at Oracle, and we aim to unpack what's new, what's different, and why Oracle believes it's uniquely positioned to lead in the age of distributed intelligence. Wei, welcome, good to see you.
Great, thank you, glad to be here.
Well, you've offered sharding in Oracle databases for a considerable amount of time, and there are major enterprise scale mission critical deployments that we know of that you support. Now you just announced globally distributed Exadata Database on Exascale infrastructure. So tell us, what's the news and what's different?
Okay, so Dave, as you mentioned, the distributed database is a very hot field right now. And the Oracle distributed database is we consider to be the most powerful feature-rich distributed database with full SQL support. Okay. And this is running production mission-critical workloads for a long time now. Okay. What's different is that if you think about a distributed database, it has many pieces, many moving parts distributed across multiple data centers and so forth. So it can be hard to configure, set up, maintain, and so forth. So we initially solved this problem by delivering it as a cloud service, right? So now it's easy to configure and self-managing and so forth, right? However, a lot of this infrastructure can be costly, right? So in this announcement, what we're doing is providing a new low-cost way to get this capability by combining distributed database with our Exascale service. Now, Exascale is our Exadata engineer system delivered as a serverless cloud system. Sorry, serverless cloud service. Okay. And what this means is that you can start small and scale up as your needs rise. Okay, so you can start really small, like with 40 CPUs and 300 gigabytes of storage, and then scale elastically up as your needs expand and come down as necessary. All right, so this drastically lowers entry point cost for this distributed database. So now we have a distributed database service that is powerful, easy, and cost-effective. And interesting enough, as you mentioned in intro, this came just in time for agentic AI.
So cloud obviously makes it easy to experiment, it de-risks the deployments. And so let's talk about agentic. I mean, it's the hot topic of the day. What are your thoughts on agentic and how your distributed database works and enhances AI workflows?
Sure. I think there are three interesting characters of agentic AI. First, it can be very high-low, because now you have machines hitting your data instead of human beings, right? Secondly, the traffic of agentic AI is very bursty. They come in doing waves, then they finish, they come in waves again later on, right? Plus, in the modern world, agentic AI must meet data residency requirements. Okay. So if you think about this, with a high load, you need hyperscale. You need the ability to handle really massive loads. Plus, you want the load to be elastic, because when the load comes, you want to handle it. But when the load goes away, you want to shrink down your hardware configuration and so forth, right? And finally, agentic AI is still accessing data, right? The data must still meet data residency requirements. Of course, all of this has to be always on, right? Because as agentic AI becomes part of your business workflows, it cannot stop, right? So if you can imagine that, for instance, if your AI is running your border controls, checking people's passports and so forth, if the AI is down, your borders, your passport control system shut down, right? And this is where we have, a mission critical, Raft replication comes in, right? This has a lot of capabilities to support mission critical agentic AI applications.
So, okay, so you mentioned Raft replication. which is a consensus algorithm. So people who may not be familiar with it, what specifically is Raft replication? I mean, there's a lot of ways to skin this, data consistency cat. So talk about your approach. What is Raft replication? Why should people care? And what's different about Oracle's implementation?
Right. So what's interesting about Raft is that it's actually a proven way to replicate data among the distributed system such that all the parties agree on what the outcome is. Okay, so it's a great way to get consistent outcomes. And so the way that we use Raft is that we provide what we call active-active replication. So that if you have a quorum of, let's say, 3 nodes, 5 nodes, and so forth, our Raft protocol guarantees that if there's a failure, we can fail automatically to one of the replicas with 0 data loss in less than 3 seconds. So that's very, very high availability. Right? And so this is of immense interest to our financial customers, for example, banks, credit card companies, and so forth, and now also with Agentic AI. First of all, we support more than just Raft, right? Because we know that real-world networks are highly variable. Some networks are very stable, right? In which case you can run Raft with no issues. Other networks are very flaky. They have a lot of jitter, they have long delays, and so forth. And that's where our other replication methods are better. And that's why we support 3 different replication methods, such that customers can deploy the one that is most appropriate for their networks.
So AI has just sort of accentuated the whole distributed database topic. The scale is very hot these days. There's a lot of players, out there. There's specialists like CockroachDB, Yugabyte is another one. Of course, people might be familiar with Google Spanner. Last year, I think it was last year, Amazon announced, a version of Aurora. So let's sort of dig in and understand why you feel Oracle's distributed database offering sets apart from these other vendors. What's unique? What are you most proud of? What's different?
Right. So there are several things, right? First, we work really, really hard to make sure it's a full feature functionality. Right? So it is Oracle database. So we get all the capabilities that you expect from Oracle, all the data types, full SQL support, and so forth. Okay? And this is important because if you don't support full functionality, it's very hard for customers to move their applications into this distributed environment. So that's number one. Right? Secondly, we are designed from the ground up to support SQL. Okay? And that's actually very unique because almost all the competitors you mentioned, they started from basically using a distributed NoSQL database, right? Then they try to add SQL on top of it. Okay. Now, as you might expect, a NoSQL database is designed not to support SQL, right? So when you try to graph SQL on top of it, there's an impedance mismatch, and many things just don't work that well. Okay. We don't have that problem because we're designed from the ground up to support SQL. Then, the other thing that we do is we are a converged database. That means the Oracle database engine can support all the different data types, relational, non-relational, documents, JSON, AI, and so forth, and support multiple workload types, right? So you can support transaction processing, analytics, vector searches, and everything in one single database. So that means when you distribute it, you get a much simpler architecture than you have to distribute multiple single-purpose databases as our computers have to do. Then, of course, we support, in terms of distribution, the most number of distribution methods, which are ways of distributing your data so that you get the lowest latency, and the highest availability while obeying data sovereignty requirements.
It's amazing. I remember well the days of NoSQL. It was like the hottest thing going, and then of course when people tried to actually do things in the enterprise, it became, SQL is became the killer app. So let's drill down into some of the things you talk about. Let's start with SQL support as a key advantage. You mentioned that many others, if not most, started with a NoSQL database and tried to sort of bolt on SQL. Many still don't support, at least distributed databases, don't support SQL. Explain why customers should care if a database does or does not support SQL, and why sort of bolting on is not advantageous.
Right. So why SQL is because developer productivity. Very simple, right? Because if you look at what Google did, Google was actually one of the early adopters of NoSQL. right? But if you watch the publications, over time, they start admitting that, gee, what developers really need SQL? What developers need SQL or develop these transactions and so forth. That's what they evolved towards building something like a spanner, right? And that's what all the other, NoSQL databases have realized. You start with NoSQL, but realize that, you wind up with proprietary APIs that you wind up with, languages that are not very powerful and so forth, right? And so SQL, the nice thing, it's a standard, right? And it's very powerful, it's very general. And so that's why everybody is moving towards SQL. Now, the issue is that people claim SQL compatibility, but very few of them actually implement the full SQL syntax with full data type support. What this means is that if an application uses data types that are not supported or use SQL features that are not supported by your implementation, they have to do a lot of rewrite to be able to move to your database, right? And so that's why by offering a very feature-rich SQL, as well as all the enterprise capabilities that customers expect, we make it very easy to move your application into a distributed database.
Great, thank you for that, Wei. Do you have any competitive takeouts or wins that you can talk about for your globally distributed database? Any examples, and if so, what kinds of environments are we talking about?
Right. So actually, we have several examples, right? For example, a major US bank is using our distributed database to meet data sovereignty requirements, right? So they had to segregate data in certain countries to meet localization requirements, right? But with our distributed database, they're able to make the whole thing look like a single logical database to the applications, right? So for example, in this case, they have data stored in India and then data stored in the United States, but the application servers are in the United States, such that the whole thing looks like a single database and the application doesn't have to change. So that's a great example, right? Then likewise, we have a credit card company that's using our stuff for credit card payment processing. And then there's internet infrastructure provider and electrical power utilities and so forth. So these are just some examples of wins for our distributed database. Okay. Now you can see these are fairly large scale mission critical applications.
Right, okay, so you can leave the data in place, ensure data sovereignty, that you meet the compliance edicts of the country or even the organization, and yet the application thinks it's talking to a single instance. Is that right?
That's correct. And that's really important. If you think about data sovereignty, the direction the world is moving to is that almost all the countries started to implement localization requirements, right? And so if you're a global company, if you have to replicate your entire infrastructure in every single country, that's very, very expensive, right? And it's really cost prohibitive in some of the smaller markets, right? By allowing your applications to stay in the original location, but just moving the data to where the country is, would drastically lower the cost, right? And make it cost effective for these companies to meet the data sovereignty requirements and still do their business cost effective.
Got it. Another thing that we hear Oracle talk about is you tout your advantage around you have a large set, maybe even the largest set of automated data distribution policies. Don't most vendors that you compete with provide the same capabilities in this regard? And am I missing something here? I mean, if not, why should customers care? Why is this a big deal if they don't?
Right. But actually, that's a great question. If you think about distributed database, how the data is distributed has a huge impact on your performance, right? So for example, you don't want your users in, say, Japan, accessing data that's in Latin America, because that's very long latency and so forth, right? And so how you distribute data has a major impact on performance. And now with data sovereignty, it has legal implications also. If you look at distributed NoSQL databases, they all started by supporting just hash, right? Hash assumes you can divide your data randomly, evenly spread across. Now, hashing obviously does not work with data sovereignty, because you don't want India data to be spread to outside of India, for example, right? And so that's why we support hash, range, list, composite, 6 different distribution methods, right? Then another one that's interesting is we uniquely support something we call value-based distribution. And that is to handle the cases where hashing doesn't work well. Hashing supposes that everybody is roughly the same. And so you just spread them out evenly, right? But in the real world, the data is skewed, right? So you think about musicians, someone like Taylor Swift is far more popular than like 99% of the other musicians out there, right? Mm-hmm. So you treat Taylor Swift the same as everybody else, you're going to get very lopsided performance, right? So that's why we offer very highly customizable distribution methods such that applications can pick and control where the data should be located to meet performance requirements, to meet data sovereignty requirements, as well as handle data skew and so forth. So we support far more than any of our competitors do, precise for this reason.
So that's interesting. Wei, I have a follow-up on that. So it sounds like you have a lot of optionality and maybe a lot of knobs to turn. If I don't want to turn those knobs or I don't have the skills, do you provide some level of automation to sort of help me optimize that?
Absolutely. So first of all, this is all done automatically. You don't have to go and say, I want to put this piece there, put this piece here, right? You have the control, right? You have the control, but you don't have to use it. So, the easiest thing to do is just say, hey, the system will just automatically spread your data around you, right? And then you can specify, for instance, subject to countries go here, countries go here, and within each country spread data automatically. So we can do all of this for you. And the key thing is that from the perspective of the application, it's transparent. The application does not know where the data is located.
Nice, okay, so you got that kind of autopilot mode.
Yes.
Do you see any patterns for use cases that are using your globally distributed database?
Yes, we do. It sort of changes over time. When we first started, the primary use case was hyperscalability. Right? People want to spread really large workloads and so forth. Right? Then we see the growth of data sovereignty. Right? That became a very hot topic because certain regulations, when they come into effect, all the companies that do business in that country have to scrap to meet those requirements. Right? Now, more recently, with our introduction of our Raft replication, we're seeing that high availability, mission critical is becoming, top of mind again, right? Because this is something that's very important to our customers. And of course, more recently, is AI agents. Right? With AI, it's large scale AI vector searches as well as being able to handle agentic AI applications.
Well, speaking of AI, let's talk about that because we talk to a lot of customers, and there's a real sort of bifurcation, if you will. You have large banks, which I know you guys have a lot of exposure in, that actually have the skills to implement AI very effectively. They're doing a lot more with less. They're not having to hire as quickly. There's mainstream enterprises that need more automation and hand-holding, but how does the globally distributed Exadata database that you're running on Exascale infrastructure, how does it help customers practically implement AI for their organizations? Can you give us sort of actionable information in this regard?
Sure. I think the most important thing is that we bring AI to your data, right? Because most companies store the business data in Oracle, right? So we want to do AI stuff. You want to do AI with your data, right? And to do this, you have two ways of doing it. You can take the data out of Oracle and put them into an external store, right? But that means you make duplicate copies of the data, you have to do ETL and so forth, right? So we think a better approach is to bring AI to your data. And that's what we've done. That's what we added vector search to your database. So this way you can do AI searches along with business searches in a single SQL statement. Okay, so that's the most powerful thing that we bring. We just bring AI to your data. Then we do is we give you, with distributed database, the ability to do this first at a wide scale. Secondly, with really high levels of availability, because now we are, proof against server failures, regional failures, data center failures, and so forth, and while obeying data sovereignty, right? So we just give you this combination of AI data with business data in a distributed manner.
So we talked about data residency and data sovereignty earlier. You just mentioned it again. And it's, I think, one of the most interesting use cases. You hear it all the time with all the sort of public policy uncertainty that's going on. Governments and organizations, are much more protective of their data. It's very clear that the proprietary data sets that sit behind corporations' firewalls are where they're going to get value out of this. So they're really becoming more important every day. So are there any other things that we should know about the globally distributed Exadata database that's again, running on Exascale infrastructure that really helps customers address these requirements?
Oh, yes. So I think, actually, thank you for asking, because actually that brought up a point that I forgot to mention earlier, which is that the key thing that we bring also is low entry point price.
Mm-hmm.
You just think about a company that's trying to establish a business in your country, right? You don't know how much business there's going to be over there. So Exascale allows you to start really small, so you can have footprint in that country, right? And then scale up the infrastructure as the business requirements increase, right? And so this is something that we can do that you cannot do in the old days. In the old days, just set up a data center, bring a stream of machines and so forth. It's just a big investment. With Exascale, it's easy. Just taking our existing Oracle Cloud region and say, okay, I want to spin up a small shard of the data, right? And then you're there, right? And so this is an easy, low-cost way to get started, and then you can then expand as your business needs expand. And also, you can also shut things down and shift things around if you have to.
So you talked about Exascale before. If I recall, Exascale, I sometimes get confused, but I think you announced it or sort of rebranded it last year. So I'm inferring that it's sort of built for the AI era. Can we do a little bit of deeper double click on the benefits that Exascale brings to customers?
Sure. First of all, Exascale is built on Exadata, right? And Exadata is our system that's custom engineered to run Oracle database most optimally, and so forth, right? And it has a lot of functionality to allow processing the hardware acceleration of common functions, including more recently, AI vector searches. So we can push down AI vector search functionality so it executes at hardware speeds. Right? So that's Exadata. Now, and Exadata can be deployed on premises, in the cloud, and so forth, right? And also, actually, it's also going to be deployed multi-cloud now with Azure, with AWS, with GCP, and so forth. And what Exascale is delivering the Exadata as a serverless cloud service. Okay? So that means you can now use a fraction of an Exadata to carry your workload. And so that, again, drastically lowers your cost. And with Exascale, we separate the compute from storage so that you can independently scale the compute and the storage, right? And you can elastically grow them or shrink as you want based on your workload demands and so forth. So that's why Exascale gives you very low entry point cost, and it's elastic, so you can scale up and down based on demands. And then what we did was we coupled our distributed database to run on top of Exascale. So now you get distributed database capabilities on this serverless, elastic, scalable architecture.
Well, speaking of that, we got Cloud World coming up. I'm sure we'll be talking about a lot of these topics, and AI in particular, and Agentic. It's October 13th to 16th in lovely Las Vegas. What can we expect to hear? What are the customers going to learn more about this show at this year's event?
Right. I think some of the big topics are going to be things like multi-cloud, right? Of course, AI, distributed database, JSON workloads, right? And of course, security topic like ransomware protection, right? And more things, right? Because Cloud World tends to be where we bunch up and announce a lot of our new technologies at once. I think that everyone who is interested in this technology should definitely plan to attend Cloud World, right? It's a chance to meet and hear from Oracle development, as well as other customers on how they're using new technologies. Right? And so this is also where customers can get hands-on experience with AI vector search, new features like JSON relational duality views, and meet all the engineers who develop all the products and features such as replication clusters, Active Data Guard, Database 23 AI, and Exadata. Right? I think it's really a can't-miss event for Oracle database users.
Yeah, absolutely. You get to these events and you can really connect the dots. You can, as you say, talk to the engineers and really push them and get all the answers to your hard questions. Wei, thank you so much, and congratulations on the announcement.
Okay, thank you very much.
Yeah, you bet. All right, what did we learn today? Let's summarize. We talked about in this discussion, and the big takeaway really is that Oracle's not just extending its database footprint, but really trying to reimagine what global scale data infrastructure looks like in a world that's increasingly defined by AI, which brings in the sovereignty discussion that we talked about, and this is just one massive distributed system. The company, Oracle, that is, betting that customers want more than just scale. They also need consistency, they need automation, they need enterprise-grade capabilities. That's what Oracle's promise is to customers. They're really the king of mission critical. In our opinion, Oracle's message is unambiguous. If you're building mission critical, AI-infused workloads with global compliance, you have to look at Oracle as a serious contender and an alternative to consider. Put them on your short list. It's something that we've often recommended. So as we look ahead to cloud world, we expect Oracle is going to double down on these themes and really keep challenging the market's assumptions about distributed data and cloud scale and AI. Now, as AI agents become more pervasive, remember, distributed transactions, that's going to explode the need for secure data residency to ensure compliance with local edicts, as we talked about. So check out Oracle Cloud World, check out theCUBE, we'll be watching. And thank you for watching. This is Dave Vellante for theCUBE Research, and we'll see you next time.